Okay, now let us just recall what we did till yesterday. So, 1 minute. Yeah, so this is okay. Till where we have went. Yeah, so we'll pick it up from here. And as we know that, like we completed SHM of the particles, and we did so many things regarding that, isn't it? Means other guys, please follow. Yeah, we started basically, but yeah, now I'll connect with the SHM because that was just the intro part of the way. So according to our introduction, 1 minute. Yeah. So from our, like, we did the introduction part, and we told like ध्यान से देखना. So in the introduction we have seen that whenever a particle is present, okay. Now let's suppose if a wave is traveling like this way, then we told that any kind of a particle which is present somewhere, this particular line, this vertical line, so also shows us the vibration of source, है ना? And if this is my particle which is present at some x distance, okay, if this is my particle which is present at some x distance away from the origin, and I want to know what is its displacement equation, then we told that this displacement equation basically, yeah, displacement equation of the wave was given as basically yt was equal to a sine omega t minus, like we wrote in this form, t minus x by b plus phi, है ना? This was our wave equation, which we talked about it. Now we'll see much more greater detail of this. Means it's not that much too much enough. Okay, so where is that diagram? Let me just pick that diagram. Oh, I think I have lost it. Okay, okay, no need of that. अब ध्यान से देखो, तो बोल रहा है कि let us just consider how it does this happens, then we can have a better understanding. So let us understand. This was my first particle. मैंने क्या बोला था? This is my second particle. This is third particle. This is fourth particle. This is fifth particle, sixth particle, and so on. If I place these many particles over here, and if I start to vibrate the source in the perpendicular direction, means the source is itself doing the SHM. मैंने क्या बोला था कि हमें मालूम है कि whatever मीन्स ये जो यहाँ से डिस्टरबेंस चल के यहाँ तक आएगी, जो इस पॉइंट पर आएगी, मीन्स सिक्स पार्टिकल पर आएगी, हमें पहले से ही मालूम है व्हाट द मीन्स व्हाट दिस पार्टिकल विल डू. मीन्स वी आर द प्रिडिक्टर्स, यू कैन से. मतलब जैसे वो हाथ देख के हॉरोस्कोप देख के बता, मतलब वो जो एस्ट्रोलॉजी वाले हॉरोस्कोप बताते हैं ये बेटा जाके आगे इंजीनियर बनेगा, तो मैं भी वैसे ही बोलता हूँ ये पार्टिकल जाके ये ऐसा कुछ करेगा, है ना? वो हमें पहले से पता रहता है. कहाँ पर? ऑरिजिन पर. कहाँ पर मालूम रहता है? Yeah, it's a general idea. So basically, if this particle is performing any kind of SHM over here, take, if this particle is performing SHM over here at any time, random time t, so it has a vertical displacement y. This particle is located at some distance x from the origin. The wave energy basically takes some time to reach over there, and that time to reach to this particle is x by v. So if I want to bring it to the origin, I need to neutralize this time, means I need to make this zero, and we make this zero by the instant at which the particle is considered, bring it back by the time taken by wave to reach over there. So the equation becomes same. I'll write it as a sine. The equation is written as omega t minus omega x by b plus phi. Is that clear or not? Now, this particular point, means this particular understanding, is called as also the displacement equation of the particle, or, or displacement equation of wave also. Take. Is that clear? So we got that this wave is also following some kind of a periodic function, है ना? Basically the sine and cos and all are these kind of a periodic function, and that's what we are going to understand from here. Okay, now why we are going to call it as periodic, that's the biggest point. We know that these sine or cos kind of graphs actually self repeat after some time, and that is how much is that? After 2 pi time, isn't it? Means any kind of sine or a cos graph will repeat itself after 2 pi time. So basically that's why we also say that the period of these particles are also equal to how much? 2 pi. Basically we say that it is also equal to how much? 2 pi. Yeah. Yeah. Guys, is this clear or not? Okay. Now, basically, the point arises that if the particle displacement is known, then whatever this particle is over here, this particle also has some velocity, also has some acceleration. Look over here. Basically, what it is doing means I'm now trying to imagine the particle. My particle is just like a case of YSHM in which means see. Okay, let us draw it vertically because you guys will not be able to pick up. I'm not in the class. I have to remember that. So basically, this is the particle which is oscillating upwards and downwards, but the wave is moving forward. ठीक. So then, if the particle, uh-huh, no, this is not the source. This is my particle. Okay, the source is also moving in the same fashion. Got it or not? But why we are not considering source? Because we write the equation through the source, but we are not going to consider it as always because we have to talk about the particle because wave is propagating always in the forward direction or not. Okay, so if this particle is oscillating upwards and downwards, so let's suppose if this particle is over here in the wave, then during this point, this is my mean point of the particle. Extreme point is its plus amplitude A, minus amplitude A, is exactly matches with the source. Now, if we know the mean point, extreme point, and we know the displacement of particle at time t, then definitely we can know about the velocity of the particle also. So how to find the velocity? We know that the displacement is given as, yeah, a sine omega t minus what is that relation? So sorry, I have written correct. Omega x by v and plus phi. Yeah, so actually they started to call this thing, they started to tell that let us just tell about this number. Basically, omega is very good. Omega is called as angular frequency. Take. But you see that this number omega by v, this particular omega by v was given a name. इसको बुलाया गया एक नाम से. बड़ा इसको बोला गया कि this is nothing or this is you can say basically इसको ऐसे बोला गया. एक मिनट मैं अच्छे से लिखता हूँ. बोला गया कि we know that for the velocity of wave is something, मतलब कुछ ना कुछ तो velocity है नहीं है. तो बोला गया कि let us define this velocity of wave in terms of some wave numbers and we call this velocity of wave as omega by k. क्या बोलते हैं? अभी के लिए अभी बस इसको नंबर रख के समझो. I'll tell you what is this basically. And k was called as, yeah, देखो. That's not spring constant. Here there is no such spring over here. Okay. No, no, no. अच्छा अब ध्यान से देखो. Let us understand what is this basically. Now you look over here. This is my wave which is created from the source over here and it is propagating. The particles are over here on the x-axis and their displacements are arranged shown by this wave diagram. Means this particular ये crest और trough के diagram से I am able to tell where my particle is right now, है ना? एक बात बताओ बेटा, look over here. When I am just generating this wave, you see that there are n number of particles over here or not? How many particles are there? Many number of particles. Yes. And many number of particles are oscillating with just one angular frequency of the source or not. I am oscillating this source with angular frequency omega, but all these particles are oscillating with respect to this omega or not. So let's suppose if a wave is generated which has some velocity v, what it has? Some velocity v. Then this velocity, must be equal to distance by time, isn't it? So we told that what is this? Sorry, speed is equal to distance by time, or speed we can say of the speed of the wave. So as we know that the distance of this wave in one time period, see the particles, this wave is traveling till over here, where it is traveling, beta, to till 1 lambda, isn't it? So we defined this velocity as distance as lambda, and 1 by time we know that it is frequency. What it is called as? Frequency. So the velocity of wave was also written as lambda into frequency. Are you able to get me or not, guys? Now, yeah, next thing was, you look over here. This frequency, if I see, frequency can be written in terms of omega also, isn't it? So, what is omega basically? Frequency, we can write omega as 2 pi f, isn't it? So basically, if I write omega in terms of frequency in terms of omega, I will get that velocity of wave is nothing. Yeah. So velocity of wave is nothing but how much? Lambda into omega by 2 pi. And then this omega was written as velocity of wave into, wait 1 minute, velocity of wave into 2 pi by lambda. What do you think? What is this 2 pi by lambda? You look over here, the total length of the particles from here to here is basically how much? 2 pi. For a sine graph, the length is how much? 2 pi. And wavelength is the particular length or wave of the, means you can say the length of the disturbance in that 2 pi time period or not. Now, if I divide 2 pi by the wavelength, then I can understand that how many numbers of such small waves are created over here or not. Basically, this whole wave is a combination of these small waves which are generated by each and every particle or not. Otherwise, it will not be possible. So basically, in 1 2 pi length, we want to know how many numbers of wave are there. So what I will do, I'll divide 2 pi by total wavelength which is generated by these waves. If I divide total length by the addition of all these waves, then I get a number n or not. Bol yes or no. Guys, are you able to get me? So basically, that's what we define omega as velocity of wave into wave number. The number of waves which are comprising in the region between 0 to 2 pi, means how many numbers of waves are present between the range of, or you can say between the length of period of a sinusoidal graph or a cosine graph. Is that clear? So this is defined as velocity of wave. Now, velocity of wave is, I can write it as omega by k. What is that? Omega by k. So then the wave equation changes to, or best wave equation, means displacement of particle is written as, yeah, yeah, tell me. Okay, so we can write it as a sine omega t, omega by v, if we'll put it, you will get it as kx plus phi. So this is called as basically the equation of wave, equation of a progressive wave. Now Let us just understand that what is this basically, what is the meaning of this. So the first important thing is velocity of wave represents that how this energy is propagating. What is it, what is the meaning of that? How energy, yeah, but the particle velocity, this velocity means this velocity of wave is horizontal, but the particle velocity is basically vertical over here on particle ऐसे ऐसे vibrate कर रहा है. Is that clear or not? So basically we will consider the particle velocity. How to find the particle velocity? So the velocity of particle in a wave is not provided by omega by k. It is just the differentiation of this displacement with respect to time. Basically, you have to say always speed of the particle. Is that clear? So if I differentiate it, I get it as if I differentiate it with respect to time, we get it as a sine. Sorry, 1 minute. A omega cos omega kx plus phi. Are you able to get me or not, guys? Okay. And let us call the acceleration of the particle as, then that is simple SHM equation, minus a omega square sine omega t minus kx plus phi. Is that clear? So these are my naturally understood, these are the natural conditioned equations of wave. But you see in the book, in many books, not in many books, every book they will say that the equation of wave is not this. It is written as a sine kx minus omega t. I'm considering the initial phi to be 0. If I write initial phi to be 0, it's not omega t minus kx, but it is kx minus omega t. Then what's the difference? Oh my goodness, that's a big logic over here, isn't it? So let us see that which one we have to utilize. Now I'll tell you one fact. I'll tell you one of the most important thing. You see that this is not given in any of the books. This is just the father of physics, Newton's Baba rebirth experiment. Okay. So Newton was born in late 1600s. I can remember how I was born. Okay. Yeah, that was my past life. Okay. Now look over here. So okay, now you see that. What is this? This is same thing what we have drawn. A source is vibrating in the what? Is that a mirror image? That's not a mirror image. So this is also a representation y, and this is my time period t. This is y and time period t. Both are sine graph only. One is going down, one is going up. That's the biggest difference. When the question arises that till now what we are studying, what we have to consider, basically any kind of a wave which will propagate is going to basically follow sinusoidal graph, that we know that the point of origin of a disturbance is from here. So from here it will be drawn, but it can be, if the source goes down, if the source goes down, the graph will be like this way, and if the source goes up, the graph will be like this way. Then the point arises, which one is correct, which one is not correct. Both are same thing. They are both following the same equation. Y is equal to a sine bracket, I do not know. Here also they are following same. Y is equal to a sine bracket, I do not know. Got it? Now look over here. Let us try to see. Let us see why this discrepancy is appearing. Now to solve this discrepancy, we will draw a slope over here. What we will draw? Yeah, we will draw a slope. Now you got the idea. You see that in the first case, this slope is making a acute angle with the x-axis, and that means this slope is positive. while this slope is negative, isn't it? Now that's the biggest thing to understand. Basically, if I'm saying something as a positive slope and something I'm saying as a negative slope, then definitely inside this region, inside this bracket areas, some difference is there. And that's what is given as the wave equation. That actually creates the original wave equation. So let us understand. If I write, uh-huh, both are not correct. That's what we have to see now. See, the slope is providing us the idea or not. For here, the slope is positive, and for here, the slope is negative. Got it? Yeah. So the question arises that which one of the following you are going to pick up? That's the biggest question or not? Yes. So अब समझो जरा कि what I'm going to consider. That's the biggest thing. Now look over here. Think of the transverse wave. If you can think of the transverse wave, then only you will be able to reply. Okay. एक बात बताओ. एक चीज समझो जरा कि let's suppose if this is my SHM, okay, and this is my mean point, this is my extreme point, and this is my another extreme point. Now I stretch the particle till the extreme point, till where I stretched it. Okay, तो एक बात बताओ, अगर if this extreme point is there, if this particle is at extreme point, then what you will see, this particle has a velocity along which direction? Opposite direction. Along which direction? Opposite. Means my displacement is basically positive. See that. But where is my velocity direction? Velocity is direction is basically negative, isn't it? Bolo yaar, balaks हाँ या ना? If I see over here, basically the displacement is negative. If I see the mean point as 0, 0, 0 coordinate, and the velocity is positive. So these are two different things. Basically these two graphs represent that what is there. One in one case, my displacement of the particle is on the right side. In another case, my displacement of the particle is on the left side. So the question arises that which one you are going to consider. Both are correct in themselves, but there is a discrepancy. What is that discrepancy? That when I take a sine, try to see, when I take this wave equation, like a sine omega t minus kx plus phi, then if you differentiate it, you get the velocity over here. Put the value of t is equal to 0, x is equal to 0, you will see that the velocity of particle is what? Positive. कैसा है? Positive. But if you take the equation y is equal to a sine kx minus omega t, what I have taken? Now again, once again you differentiate it. If you write dy by dt, then you will get minus a omega cos kx minus omega t or not? Is that clear? Put x is equal to 0, t is equal to 0. Then this velocity is basically negative, minus a omega. And this velocity is positive. Are you able to get me or not? If I put for x is equal to 0 and t is equal to 0. Is that clear everyone? Sakshi and Mala? Sorry, Sakshi and Chandra. Is this clear or not? Are you guys alive? Sakshi, Chandra? Are you here? She's not here. Okay. Okay. Okay, so see that. So basically, the velocity of particle is basically what? Positive over here. That means which is if I put x is equal to 0, t is equal to 0 in these equations, isn't it? If I put x is equal to 0, y is 0, and here velocity is positive. And here, if I put in a sine omega, a sine kx minus omega t, velocity is negative for x is equal to 0 and t is equal to 0. So these two graphs represents two different equations. Basically, this is the graph. If slope is positive, that means velocity is positive. So this graph is of omega t minus kx plus phi, and this graph is of a sine kx minus omega t. Are you able to get me or not? Got it? Which graph is this? Kx minus omega omega t. Is that clear or not? मेरी बातें समझ में आई या नहीं आई? See, so both of these means both of these have one thing in common, that they are representing the same velocity of graph, which is omega by k. Velocity of wave is same in both the cases, which is omega by k. But both one are showing the different kinds of attitudes. They have a different kinds of nature. One is following a negative slope, while another one is following a positive slope. Is that clear or not? ठीक है. So basically, 1 minute. Okay. So the question arises. So what they told is, let us just remove this discrepancy. How we can remove is that they told that let us understand one of the case, that whenever a particle is displaced in upward direction, then this particle will be also displaced in the upward direction. Whatever the intermediate particles are there, they will be displaced in the upward direction, but actually their tendency of velocity should be downwards or not. What should be the velocity of particles? Downwards. So if you look at this case, if I see this particles equation and then if I see this velocity positive equation, then that's a totally different thing now. It should not be possible. If my displacement of the source is upward and still the particle's velocity is also upward, then that is not SHM. Particle's velocity should be downwards if the source is going upwards, isn't it? I'll show you that animation. I'll show you that animation. Look over here. Documents. Let us wait. That is why. 1 minute. Where is that? Where is that? Waves. Why am I opening this? I have already my PPT saved. One minute. Yeah. Okay. Yeah. Now see that. देखो ध्यान से, अच्छे से समझते हैं अब सोचो जरा बेटा, ध्यान से देखो, ये ग्राफ तुम्हें हर चीज बता देगा आज. Look over here, guys. Please look over here. You see that? Now, you see, if my see these particles, when the source is going upwards, where my source is going, see that upwards, then this particle has a upward velocity. The downmost particles, not the upward particles. Got it or not? The upward particles has which velocity? Downwards, isn't it? See that? See that? See that? Is that clear or not? So, and if the particular source is going downwards, for this going downwards, this downward velocity should have a upward direction. Are you able to get me or not? So, whatever the source is performing, the particles are performing just opposite of that, isn't it? Then only the system will be created. So, if I am writing the wave equation y is equal to a sine omega t minus kx plus phi, which is the equation of a progressive wave, and then velocity is also similar, means whatever the velocity is there, and I'm writing that these velocities are also same in the same direction, then thus this is just a contradiction or not? Okay, so basically we interchange the relation, because this equation says that whenever my equation is whenever the particle is moving upwards, then at that time the particle's velocity is negative. So that's why we bring this equation for this graph, not for this graph. And that's why the reason the wave equation was interchanged and yt is written as a sine omega t minus, sorry, kx minus omega t plus phi. Because I want whenever the slope is positive, the basically that should mean that the particle is getting velocity of the particle should be negative. Slope positive, but the velocity should be what? Negative, such that the particle returns back to its mean position once again. मेरी बातें समझ में आई या नहीं है बेटा? See, yt represents what? Particle's equation, है ना? Velocity of particle will be what? Dy by dt. That means slope of the graph, isn't it? Now, I want this velocity to be negative. I want this velocity to be what? Negative. So the instead of changing the graph itself, change these variables, we can get the easily negative velocity such that that is why I changed a sine omega t minus kx plus phi to a sine kx minus omega t. And this represents the wave equation. Means for every point, if the slope is positive, the velocity of the particle should be negative. Wherever the slope is negative, velocity of the particle is upwards. Is that clear or not? Now you got the idea? And this is why this graph was written. Means this if this has zero phase difference, this was written as a sin kx minus omega t with phi equal to 0. Then this graph was given as a sin kx minus, you see that there is an interchange of pi degrees, so kx minus omega t plus pi. So phase gap between both of the graph is how much? Pi degrees. कितना है बेटा? pi. ध्यान से देखो, जब तुम इसको लिखोगे तो ये ग्राफ अपने आप आता है y is equal to minus a sin omega t minus kx. Pi plus theta, pi plus theta is sorry, not minus, there will be no minus, ए साइन ओमेगा टी माइनस के एक्स. तो देखो ये इंटरचेंज हो गया या नहीं हो गया? यहाँ पे हमें क्या मिलेगा? स्लोप पॉजिटिव मिलेगा. तो स्लोप यहाँ पर हमें वेलोसिटी पॉजिटिव मिलेगा, तो स्लोप कैसा है बेटा? नेगेटिव. तो हमें आंसर डायरेक्टली मिल रहा है ना ग्राफ से. इज दैट क्लियर और नॉट? साक्षी एंड चंद्रा, इज दिस क्लियर? हाँ. Yeah, second equation is accurate because no means the condition is what? Whatever where means the source equation is y is equal to a sine omega t. Okay, but the particle at that time, if source is going upwards, the downward particles are going upwards, but the upward particles are going downwards or not. So if the velocity of source is upwards, the velocity of the particle is in which direction? Downward direction. So that is the reason if I write the particle equation, basically yt represents the upward direction of the particle. So that is written as a sine, मतलब ये a sine omega t plus a sine omega t minus kx plus phi ये क्या represent कर रहा है? ऊपर के डायरेक्शन में ना. ये y कहाँ से मेजर किया गया? नीचे से लेके ऊपर. लेकिन उस टाइम पर पार्टिकल को आना कहाँ है? नीचे. मतलब वेलोसिटी अपने को क्या चाहिए? नेगेटिव. कैसे चाहिए? नेगेटिव. इट इज ओनली पॉसिबल व्हेन यू डिफरेंशिएट इट. This is the velocity of particle. You get it as a omega cos omega t minus kx plus phi. But if I put x is equal to 0, t is equal to 0, I'm getting what? I'm getting it as a positive value. But this should be actually negative. So how to get it negative? Instead of adding pi degrees over here, what we will do? Yeah, we can even substitute with pi. But instead of adding pi, we can interchange and we can write, we say that the wave equation is written as y is equal to a sine kx minus omega t. Now you got the real answer. So if you differentiate it, you will get velocity as minus a omega cos kx minus omega t. Now you put t is equal to 0, phi is equal to 0, you will see that this is a negative velocity graph. Is that clear or not? Now you got the idea? Sakshi, Chandra, hello. Okay, so this is what it represents. That's why we. Srishti, is this totally clear now? So Srishti is also basically I should introduce Srishti has also taken mathematics, and these two guys has also taken mathematics. I think Chandra didn't have taken mathematics. He have also taken, no? And both of them are also preparing for NEET. Okay. Okay. So let us see that. Let us just try to see. So this is our wave equation. Now we'll put the last conclusions once. Wave equation will means the particle position or the equation of wave is given as a sine kx minus omega t plus phi after so much of evaluation and all, and velocity of wave is given as omega by k, isn't it? So omega by k na, or k by omega, it's 1 minute, it's omega by k only, no? I do not know velocity of 2 pi by lambda. Yeah, omega by k. Correct. Totally correct. Now, and so velocity of particle is given as minus a omega cos kx minus omega t plus phi. Acceleration of the particle becomes positive at this time now. My a omega square sine kx minus omega t plus phi, and that's what we call it as. These are my at, vt, velocity time, and xt or yt graph, yt coordinates or equations of equation of a plane progressive wave. Is that clear or not? So this is our conclusion. These are our conclusion. Is that clear? So you got to know why we'll not consider k omega t minus kx. Why we have to consider kx minus omega t. We got to know about the velocity. We got to know about the acceleration. Is that clear? Hmm. So we got to know about so many things. Okay now? Now we will have much more analogy, we will have much more scenarios, we will have a much more understanding. Let us see how. Okay, and then we'll move ahead. Okay. Okay now. Sure. So the first point starts that how to measure this phi. How to measure this initial phase difference, isn't it? मतलब हम एक सिंपल सी क्वेश्चन है, एक सिंपल सा दिमाग में क्वेश्चन आता है, ठीक है ना, हरदम कोई भी इफ अ पर्सन इज देयर दे विल आस्क यू दैट बेटा if I do not start from origin then what you will do, means let's suppose if there is a initial phase gap. 1 minute, let me open my drive first. Mine drive, where is that question bank. uh, I got it. Yeah. Yes. So let us just understand this particular how to measure this phi. Basically, this phi is also known as phase. क्या बोलते हैं इसे अपन बेटा? Phase. Phase. Not space. It's a phase. Okay. So the question arises, what is this phi? So basically, let us try to understand. If we know that wave equation is written as a sine kx minus omega t plus y. Now if I put t is equal to 0, x is equal to 0, then y is written as a sine phi. Means, that means what? What is this phi? So our SHM can be started in any kind of time or not. Means, like, the point is simple, that our, let's suppose if the source does not starts from x is equal to 0 comma t is equal to 0, then what will happen? So whatever will be the initial gap that will be present in the source itself will be also appearing on these particles also over here, isn't it? One minute. Now, so if they do not, if this is, if at x is equal to 0, t is equal to 0, initial displacement of the particles are not 0, then what will happen? Basically, I'll have some phase constant to understand them, isn't it? So that's what we are doing. That if at x is equal to 0, t is equal to 0, y is not 0, displacement of the particle is not equal to 0, then how to measure this phi? How to measure it? We have a trick to do that. But there is a big question which arises. Just like in SHM, if I write phi, let's suppose if this vertical displacement is at some angles phi is equal to, means, or you can say this vertical displacement y was equal to a by root 2. How many values? A by root 2. Means this is possible at x is equal to 0, t is equal to 0. ध्यान से देखना जरा. So if I draw the graph, try to see, if I draw the sine graph, then this initial displacement at t is equal to 0 of a by root 2 has two values in the half of the coordinate itself. I mean, during the upward and downward motion, this a by root 2 appears two times. Then which value is correct? See that this is varying, this is appearing for some angle phi 1 and this is appearing for some angle phi 2. अरे बोल हाँ या ना. So basically, then the question arises that which one you are going to consider. That's a big question or not. We will have to do that, but we will have to do it in a different way. Whatever is done in SHM, this is totally different over here. So the best idea is to find the slope. The step one is to find the slope. Okay. Now, if we find the slope, then we have to check whether the slope is positive is positive or negative. This trick was developed by Dr. Anurag Mishra. These two tricks, they basically follow the velocity equations, but we can make it easy. Let us see how. देखो, जैसे मैं एक क्वेश्चन के थ्रू बताऊंगा तुम्हें, है ना, क्योंकि ऐसे बताने पे ये मतलब बहुत ज्यादा टाइम लेता है ना. तो बोल रहा है कि एक बोल रहा है कि a particle, a wave is moving, a wave equation or a wave is moving along positive x direction, है ना. A wave is moving along positive x direction, and at x is equal to 0 comma t is equal to 0, the displacement of the particle was at a by root 2. How much? A by root. Then tell me, what is the equation of wave? Now that's a big question or not? Uh-huh. Then tell me, what is the equation of wave? So if they are not asking you the original equation, so you are basically following y is equal to a sine. Uh, if they are not asking about velocity and acceleration, if they didn't have mentioned that the particle is going through this kx minus omega t, okay, so then this is my normal equation. A is equal to a sine omega t minus kx plus phi. Hi, can you? This is my normal equation now. If you want to consider, okay, let us consider that one. we can do it both ways, both are correct, but you have to specify them which what you are actually making it move. This is the original equation kx minus omega t, but omega t minus kx is conventionally written, okay. मतलब जैसे एक बात बताओ, अरे यार ये इलेक्ट्रॉन का हाल है कि इलेक्ट्रॉन जो होता है ना, मींस द इलेक्ट्रॉन मूव्स फ्रॉम नेगेटिव प्लेट टू पॉजिटिव प्लेट और नॉट. But how do we consider the current to go from positive to negative? Actually, current is moving like that way. Yeah, so conventional is A is equal to sine omega t minus kx plus phi. If nothing is given, use this relation. Okay, but means it's just written a wave is no, it will just say the wave is moving in the positive x direction. This is my equation. If it says a string wave is moving, a particle wave is moving, a sound wave is moving, use these relations. Okay, I'll come on that. I'll definitely come on those kind of a question. You'll see that. In general, you have to say that. Yeah. Hmm. Okay. In general, this is my equation. In general, just y is equal to a sine omega t minus kx. I have to follow. Okay. But in the case of particle motion, in the case of particles of the SHM, I have to consider which equation of the SHM? These. And both are correct. Both are basically correct. There is no change in that. Okay. ठीक है. Yes, tell me. ए कितना कितना आ रहा है? No, no. We will see that. That's why I told you that what will happen actually. Now, basically, if I put, अब ध्यान से देखो, when we put x is equal to 0, t is equal to 0, we will get that a y is equal to a sine. This is 0, and phi I have to put. Now, you look over here. If I put at this t is equal to 0, x is equal to 0, y value is a by root 2. How much is that? Replace that. Then you will get that sine phi is nothing but 1 by root 2. How much I am getting? Sine phi as 1 by 2. But then the next step is draw the sine graph. Remember that. What is the next step? Draw sine graph. And then I'll kill you. Okay, now look over here. Then the next step, first step was writing this sine phi for t is equal to 0, x is equal to 0. Then draw the sine graph. That's a sine graph. Okay. Huh? What we? No, we'll not shift it. We'll not. We'll just consider it from 0. I'll tell you why. Because the answer will come like that. Sine graph is never ever going to shift. How come it will shift? It will never ever shift. Who said that? Now, so it's no, no. Let us see how it. What does how I'm including with 0. You see that? No, no, means the graph can shift something like this way. Okay, so he's trying to say that, but that is not possible. That's just not possible because the motion starts from t is equal to 0, x is equal to 0. You are correct. Mathematically, you are totally correct, but we'll not consider that. Okay, so then how we are going to bring it means that is mathematically we can say we are correct, but the point is still I need to consider this. मतलब ध्यान से देखो बस एक बार समझो जरा, मैं बताऊंगा पूरी रीजन बता दूंगा है ना. अब ध्यान से देख जरा कि बेसिकली व्हेन वी आर राइटिंग दिस y is equal to a sin omega t minus kx, अगर हमारे पास इनिशियल फेज है at x is equal to 0 and t is equal to 0 and you got x sin phi is equal to 1 by root 2, basically you draw the simple sin phi graph And then this value is positive 1 by root 2. Now you look over here, this 1 by root 2, just mark it on the y-axis 1 by root 2, draw a horizontal line. You will see that this one, yeah, basically this 1 by root 2 is possible for how many points? 2 points. Now your answer has appeared. This phi has appeared for two values, but then the question arises, which one I'm going to consider? This value is at sine. No, 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 no. This is a little bit different now. Okay, so that is of SHM. Okay, now this is at pi by 4, while this is at 3 pi by 4, isn't it? है ना? तो ध्यान से देखते हैं हाउ टू राइट इट। आई टेल यू वंस अगेन कैसे लिखते हैं बेटा, कि मान लो अगर ये ग्राफ है ना, तो जो पाई बाई 2 के पहले वाला रीजन है, यहाँ से यहाँ तक का रीजन है, इट इज फ्रॉम like whatever angle is there, ठीक, but the reason from here to here it is written as pi minus theta, which you are getting from here to here it is pi plus theta, and from here to here it is 2 pi minus theta, where theta is the value or phi which you are getting for 1 by root 2. Got it or not? है ना? तो ध्यान से देखो, या लेट्स, ओके, 1 मिनट, देख ध्यान से देख, ये साइन फाइव इज इक्वल टू 1 बाई रूट 2 कितने वैल्यू के लिए आ रहा है? 5/4 साइन 45 इज इक्वल टू हाउ मच? सो साइन 5/4 इज 1 बाई रूट 2, ठीक। तो देन these 1 by root 2 can have many values. How, where it is possible, beta? So look over here, basically if you are considering, means if you are considering the sine graph over here, then this is just the angle which I am getting. I consider this angle as theta. So from 0 to pi by 2 range is marked as just theta. But if I am getting any kind of intersection over here, then that point is written as pi minus theta. Okay, and if I'm getting intersection over here, somewhere over here, then that angle is marked at from here to here as pi plus theta. And then if this intersection is over here, then this is marked as 2 pi minus theta. Are you able to get me or not? Now you got the idea? Sakshi, you got the idea? Okay, so this is how we do it. Okay, now let us just see. Let us just see. So this angle is pi by 4. This angle is 3 pi by 4. Now, what you have to do, draw the normal wave graph. 1 minute, sorry. How I'm going to do is simple. Draw a normal wave graph. The graph is like this way. Okay. Sorry, 1 minute. This is not meant. Yeah. This is the normal wave graph which we are following right now. ठीक है ना? अब ध्यान से देखो, when it has some kind of phase, means if it has some kind of initial phi, the graph will be drawn like this way, isn't it? This is my original graph. 1 minute, let me draw. अरे बाबा, ठीक है, समझ में आ रही है बात? Now, so this was my second step. Okay, now draw the original graph. Since this phi is positive, a by root 2 is positive, shift the sine graph in the positive direction. Okay, and then shift this graph a little bit rightwards. Where you shift it? Can you listen me, guys? Where you have to shift it? Towards the right. Now you see that this top point has went where? Downwards or not? When I shift the graph rightwards, shift graph rightwards. That means at this instant of the time, velocity of particle is not in the upward direction. Where it is, beta? It is in the downward direction. Where it is? Downward direction. So if it is downward, that means velocity should be what? Negative. Then you draw the slopes over here. You draw the slope. The slope of the graph of sine represents what? Velocity. Now see where where the slope is negative. It is negative at 3 pi by 4, and the value of phi is just 3 pi by 4. So see, Here what I'm getting, the velocity to be what, negative or positive? Negative. Then draw the slope. Since we are following the conventional equation, then if I draw the slope, the negative slope will represent the negative velocity now. So for what angles it is showing? 3 pi by 4. So therefore phi is equal to 3 pi by 4. So equal. That's no, no, no. See, hey, you only tell me every wave is a progressive wave over here or not. The wave will propagate towards right direction or not. So if I shift it right, the wave shifts downwards. That means this upward particle has came downwards. So velocity is negative. Got it? Okay. So to understand the propagation of particle, okay, where the particle is going from that point. Uh, what? Yeah, wave is propagating. Basically, I'm saying you that we are taking it right. We are just moving it right so as to understand where this particle is going. This wave is not going anywhere. See, if this my particle is over here, where is it going to go? How come we can understand that? How will you be able to say that? The way is, देख ध्यान से समझ जरा इमारता said. Let's suppose if this is my wave and this is my particle, I don't know where this particle is going. Oh, let us just consider this particle and let us just consider this particle. Where these two particles are going? How will you say that? Do you know any answer of that? The slope does not provide you the answer. So what I will do, I'll just do a shift in the graph. I'll just do the shift in the graph. If I shift it rightwards, then I can tell, 1 minute, where it is going. Yeah, कुछ इस तरह से ऐसा है. So basically, you will see that whatever the particle was over here is this particle has went down, but this one has went up. Means for this particle is going down while this particle is going actually upwards. Got it or not? So it's not, we are not shifting the graph. We have just invented a method to understand where the particle is moving. Because normally on the y-axis we have to do, what we will have to do? ध्यान से देखो, what we'll have to do? We'll have to differentiate this equation, then only we can tell it, isn't it? But differentiation, actually what you are doing with the differentiation, you are shifting the graph with some different change in, with a very small change in time or not. So that's why we shifted towards the right. Got the idea of Sakshi? हाँ हाँ हाँ. कौन सा रीजन, कौन सा पार्ट? See, you see me, this is yt equation, displacement equation. I differentiate it to get the velocity dy by dt. But what is this? This is just a little bit change in time and a little bit change in position or not. And that's what we are doing. We are changing a little bit change in time and we are changing the little bit of change in position to understand where this velocity is present. That's all. We can't, because see here the slope is not going to say you anything. Because right now I'll tell you, I'll show you one thing, I'll show you one case. Hmm. I told you, let us just understand one case. This was a case of a particle of a graph which was moving in positive x direction. Now let us consider the same graph with x is equal to 0, t is equal to 0, y to be equal to a by root 2. But, what is what is the what is the okay, omega t minus kx plus 3 pi by 4. Okay, okay, yeah. So let us consider the same question. Let us consider the graph is going towards left. Now this graph is going towards left. Now you have to tell me what will be the value of phi. Phi is equal to what? Huh. Why 3 pi by 4? Once again, I'll tell you, when I shift the graph, the velocity becomes negative. Once again, I'll just tell you, you find the wave equation, you find out sine phi equation, second step. Third step, draw the sine graph. Then you calculated that 1 by root 2 plus 1 by root 2 is possible for two values, pi by 4 and 3 pi by 4. Then what we do, we draw the normal progressive wave graph, shift it little bit rightwards because the wave is going rightwards. We found out then when we shift it rightwards, this upward point shift downwards, that means velocity is negative. If we draw the slope at these intersections, we found out that this slope is negative. That's why we consider the angle phi to be 3 pi by 4. Yeah, think. Okay, now, first of all, if a wave is going left, let us just clear it out. If a wave is going left, y is written as a sine. We are solving conventional wave equation omega t plus kx plus phi. X becomes negative, na? Huh? Yeah. Okay. So if we have y is equal to a sine omega t plus kx plus phi, basically a left going wave is represented by y is equal to omega t plus kx plus phi. Are you able to get me or not? Now, once again, if you put x is equal to 0, y is equal to 0, y is equal to a by root 2 at such value, a cancel. That means once again sine phi is equal to 1 by root 2. Draw the sine graph then. Okay. Oh, sorry. The third step, simple. अरे बहुत आसान है यार, कुछ नहीं करना है तुमको, और आसान बता रहा हूँ. Just draw the sine graph after that with respect to phi, which is 1 by root 2. Draw the horizontal line for 1 by root 2. Okay, you'll see that there are two intersections for this 1 by root 2 possible. Now, the wave is going left. Draw the wave graph, normal wave graph. Okay, and then we shift it towards the left. Correct. We simply shift it towards the 1 minute. Sorry. Okay, now if I shift it towards the left, since it is a left going graph, what will happen? ओ बेटा जी, किस्मत की हवा कभी नरम, कभी गरम, कभी गरम गरम. This is a by root 2, not even 1 minute. Let me just draw this graph properly. 1 minute, sorry. This graph will be like very less in the, yeah, something like this. Eh, sorry guys, I'm just drawing. Yeah, now it is kind of good. Now this is my 1 by root 2 because maximum is for 1, isn't it? So this is my graph. Now it is a left going graph. If it is a left going graph, what will happen? You shift it left. So when you shift, uh, yeah, something like that will appear, isn't it? Sakshi, Mala, sorry, Sakshi and Chandra. So this point has went where? This point which was downward has went where? Upwards. So velocity is, yeah. So if I draw the slope, velocity is positive. Slope of sine phi. Slope of this y graph is simply represents velocity. So I have to consider this is pi by 4. We know that, and this is 3 pi by 4. This represents velocity negative. Yeah, this represents velocity positive. So that's why we are going to consider the particular point of phi as pi by 4. Now you got the idea? Arey Baba, minus k, that is totally lost over here, na? Is it related with that? No. Why? We take the. You tell me one thing. If I take y is equal to a sine omega t minus kx or omega t plus kx, velocity equation is still same. A omega sine cos omega t. If this is plus, it will be plus. If this is minus, minus kx. Why? Because we are taking velocity as differentiation of y with respect to time, not with x. Okay. Now you got the idea. So this is why here pi will be pi by 4. Now you got the idea or not? Is this clear, everyone? Okay, so this is what we wanted to tell about today's important things. What were those? That if I write any kind of wave equation, it has two different forms. The normal conventional form is a sine omega t minus kx plus phi. But if I see the particle movement, then if we want to write the wave equation of the particle, it is going to follow basically a sine kx minus omega t plus phi. The reason behind that is whenever the source goes upwards, the particle goes downwards. Means whenever the source moves from mean point to extreme point, the particle's velocity is basically from extreme point to mean point. Is that clear or not? The next was how to write the phi. First you solve for the equation of phi for t is equal to 0, x is equal to 0. You'll get some value of phi. And then what you do, you shift the graph little bit leftwards or rightwards. You will shift the graph little bit leftward or rightward. If you see the velocity to move upwards, if you see the point to move upward, the velocity is positive and the slope positive will be taken. If you see the point to move go downwards, you will have to take the velocity to be negative. Got it or not? Understood? Easy peasy teasy. Okay. If it is understood, then let us bring one more last thing, and that is called as the linear wave equation. So give the heading the linear wave equation. Just like SSM, this is also something which we will understand. Okay. Give the heading linear wave equation. Means whatever we have understood, displacement, velocity, and acceleration. But that displacement, velocity, acceleration must also should follow some kind of equation of a wave. So we will write that. We know that y is given as a sine conventional. We are following omega t minus kx plus phi. This is my conventional equation. Then velocity along y direction upper time t is given as a omega cos omega t minus kx plus phi. That's my velocity. If you find the acceleration, it is minus a omega square sine omega t minus kx plus phi. These all are my different equations over here. ठीक है ना? अच्छा, if I look for V max, then maximum velocity is a omega. Similarly, if I look for maximum acceleration, that is minus a omega square. Is that clear? If I do not write negative, we can still omit this negative sign for our sake of convenience. Okay. ठीक. अब ध्यान से देखो. Now let us understand this. Now let's suppose if I differentiate this y, this was dy by dt. This is d2y by dt square. 1 minute, isn't it? Now let us do the, this is first, this is second, the third calculation, which is dy by dx. If I do that dy by dx, I'll get it as minus a into x, sorry, minus a into k into cos omega t minus kx plus phi. होगा या नहीं होगा? Similarly, if I find d2y by dx square, then it is written as minus k square a sine minus minus plus it will become, sorry, it will become plus now. No, no, no. Minus, it will be minus minus. Three minuses are appearing. So sine omega t minus kx plus phi. You got the idea, guys? तो ध्यान से देखो, basically out of these four relations we get something out of it. Yeah, we can relate the time variable and the position variable. We can write the first equation of that, and the first equation is dy by dt can be written as, if I take the differentiation dy by, if I take the, if even if I take any kind of division or something like that, then dy by dt can be written as easily minus omega by k dy by dx. So this is called as the linear wave equation of the graph. Means variation of particles position with respect to time is nothing but minus omega by k. Variation of particles position with respect, variation of particle with respect to position. अब ध्यान से देखो, सुनो जरा, ये है क्या चीज, dy by dt है क्या? वेलोसिटी ऑफ पार्टिकल. अरे कुछ तो बोलो. dy by represents what? Velocity of particle or not? And omega by k is what? What is omega by k? That is velocity of wave. V of wave is omega by k. So minus velocity of wave into dy by dx, which we also call it as slope of the graph. Got it or not? So velocity of particle is nothing but slope into the velocity of wave at any point of the graph. Is that clear or not, guys? Okay. Is these other guys are alive? Okay, guys. Other guys. Sundra. Okay. So velocity of any particle at any point of the time in any kind of position on the space or the wave graph, just it is velocity of wave which is already known to us into the slope at any point. Got it or not? So that means इसका मतलब क्या है कि अभी 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 मालूम चल गया ना आसानी से कि if slope at any point is negative, velocity of particle कैसा रहेगा बेटा? Positive. And if slope at any point, अभी वही रट रहा था ना, is positive, velocity of particle is negative. मेरी बातें समझ में आई या नहीं आई? Is this clear? ठीक. तो तब से वही रट्टा मार रहा था ना कि अगर पार्टिकल अगर जैसे हम ऊपर जा रहा है तो पार्टिकल को कैसा आना रहेगा बेटा? नीचे. कैसा आना रहेगा? नीचे. ठीक है ना? ठीक. Now, and this concept of this negative and positive, whatever is this, if see, these equations are possible for only conventional cases. These equations are lost when we just include this equation of the velocity of wave, that yt is equal to a sin kx minus omega t. Everything is totally absorbed over here. Why? Because already you have included that whenever the particle goes up, the velocity becomes negative. That's all. Is that clear or not? So that's why this is that was, yeah, that was made later on. This was the earlier one, just like in the current case. So that's why we are following still the conventional methods. Okay. 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 आगे बढ़े. ठीक. हाँ बोलो. You got it? Just equate this first equation and second equation. Okay, now let us just equate this third equation and this fourth equation. Now once again you will get some relations. Okay, and that relation is, if I write equate, so I'll write that equation first of all. The third equation is d2y by dt square equation. So d2y by dt square, yeah, I'm going back only. So d2y by dt square is this relation and d2y by dx square is this one, isn't it? Now if we try to equate, sine and sine will get cancelled, amplitude and amplitude will get cancelled, but I will be left with, oh, Inky Pinky Ponky, Daddy had. Let us see. I'll tell you. These mathematics will not be understood if you will not write the equation. Just like here, we got why we equated that, because there was a reason that any point I know the velocity of the particle just by finding the slope of the graph and multiplying with the velocity of the wave. Got it or not? Yeah. And now I'm going to equate 3 and 4. Okay. Means, see that simple. d2y by dt square is what? I'll write it. You will see that d2y by dt square is minus a omega square sine omega t minus kx plus phi divided by d2y by dx square. Beta, what is that? Divided by, yeah, so almost I have divided that only now. Okay, okay. My mistake, guys. I'm a bad follower of English. I'll learn from Queen Victoria after stealing her daughter, God or not. Okay. So, she died? My goodness. Okay. Now look over here. So sine and sine once again got cancelled. A and A got cancelled. Negative, negative got cancelled. What I'm left with once again, d2y by dt square is equal to minus, no, it will not be minus, omega square by k square into d2y by dx square. है ना? Now you look over there. This is going to represent your acceleration of the particle, and that is omega by k is velocity. So velocity of the wave is square into d2y by dx square. So once again, this is nothing. Basically, why we call it as equation of wave, because इन द वेव, ध्यान से देखना जरा, इस वेव में दिक्कत क्या है बेटा, तुम लोग अभी नहीं समझ रहे हो. एसएचएम क्या था? एसएचएम एक सिंगल इक्वेशन था, ए साइन ओमेगा टी प्लस फाइव. ध्यान से देख, इसमें वेरिएबल सिर्फ एक है. वेरिएबल कितने हैं? एक. लेकिन इस ट्रांसवर्स वेव में बहुत बहुत ही कॉम्प्लिकेटेड है, क्योंकि यहाँ पर पूरी चीज चेंज हो जा रही है. यहाँ पे हजारों पार्टिकल्स पड़े हुए हैं, हर पोजीशन पे हजार पार्टिकल्स हैं. पहले क्या था, एक पार्टिकल एसएचएम कर रहा था, ऐसे ऐसे घूम घाम घूम कर रहा था, तुमने इक्वेशन लिख दिया, सब बात बराबर. अभी क्या है, कितने पार्टिकल्स हैं? हजार. सब अपने आप में एक एसएचएम कर रहा है. कोई भी ऐसा पार्टिकल नहीं है जो रेस्ट पर पड़ा हुआ है बेटा. तो हर पार्टिकल की एसएचएम अलग अलग वे में है. मतलब ये पार्टिकल यहाँ पर है तो ये पार्टिकल उसी टाइम पर यहाँ पर है, ये पार्टिकल उसी टाइम पे यहाँ पर है. हमें पता ही नहीं कि सारे पार्टिकल्स कहाँ कहाँ पर है. हर पार्टिकल की अलग अलग पोजीशन है, अलग अलग टाइम पे. लेकिन इतना पता है कि जो ये पार्टिकल कर रहा है वो ये भी पार्टिकल कर रहा है कुछ ना कुछ देर पहले. इज दैट क्लियर और नॉट? So that's how we wrote the wave equation. Here there are two variables. First is the position, because I have to consider different number of particles. Second one is the displacement along the vertical direction with respect to time. So here I have how many variables? Two. The first is the position of particle. Second one is the position of the particle along the vertical line. So that's why this becomes different. Why it becomes different? Because in one direction I have I have no acceleration, only velocity of wave is there in horizontal direction. But in a vertical direction, I have velocity of the particle and acceleration of the particle also. Then how to relate these two quantity with this velocity of wave is the biggest task, and that was done right now, which we derived over here. Got it? And that's what we told as linear wave equation. Ta-da-da-da, boom boom. Is that clear? Now you guys got it? Sak, now you understood why this is very very important, and that's why we call this as d2y by dt square, as it's not a slope, it's the acceleration of the slope beta. dy by dx is the slope, d2y by d of the graph. Yes. Okay. So this is called as linear wave equation, linear wave equation of transverse wave or plane progressive waves. Okay. That means the acceleration of a particle is provided by this equation, where it is dependent upon velocity of wave because there is no acceleration of wave into the variation of the particle with respect to position. Got it or not? ठीक. अब देखो ये चीज अभी तुम्हें दे दिया गया, तुम्हें ये फॉर्मूला या रट्टा मारना है और कुछ इक्वेशंस को सॉल्व करना है. अभी तुम्हें इसको यूज नहीं करना है. क्यों यूज नहीं करना? इसकी जो बिगर डिस्क्रिप्शन है बेटा, इस चीज को हम सॉल्व करते हैं. ध्यान से समझना कि when you will solve this equation once again, when you will solve this double differentiation once again, you will find out that the wave equation is totally identical which is coming in the practical cases. Word or not? जैसे मान लो मैंने एक लाइट को फेंका, तो लाइट का जो वेव इक्वेशन जो मॉनिटर जो तुम्हारा डिटेक्टर पिकअप करेगा और बताएगा तुम्हें, वो इस इक्वेशन को सॉल्व करने से तुरंत आ जाती है. इसका मतलब दिस इज वन ऑफ द मोस्ट प्रैक्टिकल इक्वेशंस प्रोवाइडेड एवर. वर्ड और नॉट? Now you got this. Well, now you got the idea, Sakshi. Chandra, is this clear, Srishti? Okay, so till this we have done. Tomorrow, now this was all the wave equation, understanding phi, the conventional method, the conventional transverse wave, different cases of waves. Tomorrow we'll do some more problems related to that, and then we'll do the velocity of wave on a string and stationary waves. Is that clear or not? Tomorrow you have the class also. Okay, तो तब तक के लिए टाटा बाय बाय एंड हाँ, tomorrow the class